Hello, Professor Sargent here with you again. We're going to take a look at another example of applying the simplex method. There are going to be more constraints, more variables, but on the other hand, luckily, we're only going to need to go through one round of applying the simplex method before we've come up with the optimal solution. So let me bring up the screen. Okay. So this is the standard maximization problem that we have to take a look at. And remember that for the constraints, we have that less than or equal to. We have to add the slack variables, possibly standing for some surplus that's not being used. So on that first constraint, add the surplus variable s sub 1 to make that equal, because working with the augmented matrices, we have to have equals, not inequalities. So here we go. Adding the slack variable to the first constraint, the second, the third, and finally, we also have to subtract everything over to the same side as p in the objective function to get equaling 0 on the other side. I'm now going to turn that into the initial simplex tableau. The first row. Now we have the second as well, the third, and then the objective row. Remember that you look for the most negative, i.e., find a negative in the objective row with the greatest absolute value. So the most negative entry there is the -2. That's going to make column 3 that we got from the z's. Column 3 is going to be our pivot column. Then we take a look at the ratios from the other rows of what we have over on the right-hand side, divided by things in that column. We look for the least positive ratio. So we've got 60 over 1, 100 over 2, and 200 over 3. The smallest of the three of those is the 50, and that's going to make row 2 our pivot row. We're looking at the intersection of column 3 and row 2 at that 2 that I've underlined. That's going to be our pivot element. All right, so what next? Well, since that is a 2, we're going to multiply everything in that row by 1/2 so that we can turn that into a 1. So 3 times 1/2, 1 times 1/2, 2 times 1/2, 0 times 1/2, 1 times 1/2, 0 times 1/2, 0 times 1/2, and 100 times 1/2. The rest of this, once you've got that 1 and you've replaced row 2, now that we've got a 1 and we've changed all the rest of row 2 there, we're going to use that new row 2 to change the 1 above it in that column to a 0. Remember, we now have a 1 here in row 2. So what that's going to take is the negative of row 2 plus row 1 to get a new row 1, because you'd have -1 plus 1. The -3 times row 2 plus row 3 that I'm showing there to get a new row 3. Well, again, we now have a 1 in row 2. So -3 times 1 plus 3 will give us 0. And similarly, a +2 times the 1 that we'll have right here 2 times 1 plus a -2. That'll give us a 0 in row 4, the objective row. So what we'll be doing with this row 2 is multiplying it by 2 and adding it to row 4. I'm going to show this both on a TI-84 and on Excel. So here we go. I do have a previous video on doing row operations on a TI-84. However, I want to speed this up a bit. There's a reason why I did not show some shortcuts before. Let's see here. If you already know how to enter a matrix into a TI-84, you can skip ahead a bit. But I press second and matrix, and then I go to the far right of that, and I'm going to tell it how many rows going this way and how many columns. So 4 rows and 8 columns. And then I take the time to enter each of those values. Once that's finished, then I'm going to show you how to do the row operations a little more quickly than what I showed previously. I've stored this as matrix A, by the way. So then when I do second and quit, and then I select matrix again, second and matrix, and then go over to math, I'm going to scroll through some things. And I want you to notice that one of the things that you're going to see is RREF. That would be about putting general matrix into row reduced echelon form. The problem is that with the simplex method, although you start with a square matrix, same number of rows and same number of columns on the far right hand side, the simplex method is moving where the unit columns are. That's why I didn't show it previously, because one, I expect you may have an instructor that wants you to show more work, and number two, that now that we're applying the simplex method, we're not looking to put something in row reduced echelon form. So I scroll down so that I can change row 2 to get the 2 that I'd underlined, change that to 1. That took multiplying by 1/2. So I selected times row towards the very bottom. I have to tell it what I'm multiplying by, comma, the comma is above the 7, second in matrix. I have to select the matrix that the information has been put in this case, matrix A, and then I tell it which row of matrix A that I'm multiplying by 1/2, and that was row 2. And sometimes you're going to have to scroll back and forth, left and right to see everything. If you need to have that as something exact, as fractions, you can press math and then the very first option will convert things back to fractions. One very important thing is to store this new result back in matrix A, because we then want to use that new row 2 to affect the changes on the other rows, specifically to turn column 3 into a unit column. So I press store, second in matrix is stored in A, pressing enter. Now what I want to do, instead of multiplying a row by just a number, I want to take a multiple of a row and add it to another row. So I chose times row plus, and we tell it, first of all, what we're going to multiply the pivot row by, comma, what matrix it came from, which row are we taking a multiple of? Row 2 is our pivot row, and that's going to get added to row 1. Now you might be able to immediately follow that up with storing it back in A. If not, get the result, and then before doing anything else, store it in A. I've scrolled left and right there to see what the results are. I'll show that a little bit bigger here in a bit. Storing it to A. And with the newer TI-84s, I can scroll back, copy and paste. And what I'm going to do is, since I still want to use row 2, the pivot row, from matrix A, what were the other multiples we needed? And what were they being added to? Okay, so we've done the row operation on row 1. Now we need to take -3 times row 2 and add it to row 3 to get a new row 3, followed by +2 times the row 2 plus the old row 4 to get a new row 4. So back to seeing that. Like I said, I scrolled back, copied and pasted the command. If your TI-84, if that's what you're working with, does not allow you to do that, then you'll have to go back in to the star row plus. So remember, you have to tell it what multiple of the pivot row, what matrix that's coming from. Our pivot row is the same, so I had to change what I'm applying it to, in this case, row 3. And then I'm storing that again to matrix A. Finally, for changing the objective row, row 4. Tell it what multiple you're taking of the pivot row, comma, what matrix that is in, comma, which row is the pivot row, row 2, and last, what you're applying that to. In this case, I've told it to store it to A right away. And then, because there are a fair number of columns, I'm having to scroll to the right to be able to see each row and each column. So this is what I've come up with. Because for the X column and the Y column, you do not have a unit column. That's telling us that X and Y are both 0. Z, we do have a unit column there, but the 1 is in the second row. So we trace over to the far right to see the 50 in the second row. And that's telling us that Z is 50. Also, S sub 1 for slack variable, that has a unit column. So we see that S sub 1 is 10. S sub 2 and S sub 3, well, S sub 2 doesn't have a unit column. But S sub 3 does. So let's see, we saw that Z was 50. S sub 1 is 10. S sub 2 is 0. S sub 3, the 1 in the unit column is in row 3, so we track over to the far right. S sub 3 is 50, and that is producing a p-value of 100. And notice that there are no negatives in the objective row anymore. So this is giving us the optimal solution. You don't always necessarily write it that way. You may just want to know what X, Y, and Z are and what maximum that's producing. So you may just want to see those three producing a maximum of P equals 100. However, by including this information here, I want to show something. For one thing, you can see putting in 0 for X and Y and 50 for Z, that the way we originally wrote this linear programming problem, the standard maximization problem, that gives you P equals 100. But also, we can see that 50 plus 10 will give us a 60. We've got some surplus of 10, whatever that first constraint stood for. And then in the second one, well, S sub 2 was 0, so 2 times 50 is exactly 100. On the third one, 3 times 50 is 150. S sub 3 was 50. We've got some surplus of 50 in whatever the third constraint stood for. Now let's take a look at this on Excel. We should get the same thing. All right, so we had column 3 as our pivot column and row 2 as our pivot row, intersecting at the 2 that I'm showing in red. So the first thing we need to do, notice here, by the way, on Excel, I can label what each column stands for. We need to multiply everything in row 2 by 1/2. So notice I'm typing equals 1/2 with parentheses around it times, we'll go to that first entry of row 2, pivot row, and then select, go to the lower right corner and drag, and it fills in all the rest. Now that we've got a 1 there in that pivot element, we want to use that to turn the 1 that was above it in row 1 into a 0. So we're going to multiply this new row 2 by -1 times the entry in the new row 2 plus the corresponding entry in the old row 1 to get our new entry in row 1. Select, lower right hand corner, drag it to the right. Do something similar for row 3. Underneath that pivot element was a 3. Now that we've got a 1 in row 2, -3 plus 3 will give us 0. So -3 times our new entry in row 2 plus our corresponding entry in the old row 3. Drag that. Now we've got a 0 there. And finally, we've got a -2 in that column. 2 plus negative 2 would give us 0. So I'm going to take positive 2 times what we've got in our new row 2, times, plus our corresponding entry in our old row 4 to get a new row 4. And we can see, as before, that there are no more negatives in the objective row. So we've reached our optimal solution of p equals 100, produced by, well, the only, quote, regular variable there, z. That's the only one with a unit column, so z equals 50. X and y, because those aren't unit columns, are 0. In other words, although this is with 3 variables, the graph would be 3-dimensional, the corner point that produces it is along an axis. All right, that's all I've got for now. I hope this helps. I'll see you soon.